Can you hear me okay?
Yeah, hear great.
Yep, okay. All right, great. As Eric said, my name is Mark Beach. I'm a consultant with Bennett Adelson. I've got about 20 years experience in IT. I work for everything from 60-user environments down to 2,000-user environments. I worked on internal systems, companies that deliver SaaS-type solutions. I've got a background in Active Directory, VMware, Citrix, and then more recently into Azure and ADFS and more sort of cloud-based initiatives. Excuse me. First of all, I just want to define a disaster. So when I first was introduced to the concept of disaster recovery in the early 2000s, my boss at the time described the scenario where he said, imagine a jumbo jet crashes into this building, it kills all of us, and it wipes out all of our IT systems. We need a plan where someone with no prior IT experience would be able to fully recover all of our systems from one document. And this is a kind of a scenario that I've heard many times over the years, and it's somewhat flawed in many ways. But if we first talk about the scope, if we actually think about our typical disasters, we're very focused on these big-scale disasters that wipe out an entire data center, and we absolutely should be prepared to recover from those kind of incidents. But if we look at the facts and the statistics, quite often, or the most common disasters are small-scale disasters that would affect, like, maybe a PDU in a rack goes down, takes out a small number of servers, or the human error factor, 30% of disasters in this graph here, or maybe a switch goes down and just takes out a few machines. And we really need to be able to scale our disaster recovery effort to handle that kind of disaster, not just the big disasters. And the reason this is important, if we look at there was an IBC survey done in 2015 that estimated between 1.25 and $2.5 billion were lost on unplanned downtime. And a study in 2017 showed that every minute of downtime for production systems could cost between $936 and $17,244 per minute. And 90% of businesses that don't have a DR plan will fail after a disaster. In addition to that, in 2017, we saw ransomware detections were up 90%, but 96% of companies were able to survive them if they had a good, reliable backup and DR solution in place. 30% of businesses out there have no disaster recovery strategy in place, and 1 in 3 businesses were unprepared for disasters despite having a plan. So it's definitely something we all know we really need to take seriously. And when we talk about DR, the two main factors that we need to consider are our RPO and our RTO. Our recovery point objective deals with how much data can we be prepared to lose in the event of a disaster. And this is limited by the solution that we have as well. So if you have a traditional DR solution, backup solution, and your recovery plan involves loading operating systems on servers, recovering a tape from somewhere from last night's backup, your recovery point is going to be hours, not minutes. And as we just discussed, that can get very expensive. The other big factor is how long it takes us to recover, or how long we can be without those systems. And again, in an ideal world, this will be minutes, not hours. But with a traditional system, we're talking about this whole process of engaging the DR process. And again, it can take a long time. It costs a lot of money. With the traditional DR models, as you all know, it's expensive. You're probably going to have either rented or purchased additional hardware. There's a good chance you're going to have a DR facility that you need to pay money to. You're also going to have multiple solutions. So you may have one solution for your physical servers, another solution for your VMware implementation, another one for your Hyper-V. And so that adds a lot of complexity. And this is all things that we have to deal with in a disaster situation, understanding which is the right plan and how to recover things. Traditionally, it's always also very expensive and difficult to test because we also need all of these off-site locations and additional hardware every time we want to test things. So typically we don't test as much as we should, and when the things that we learn from our test process, it's difficult to retest quickly and effectively. As we discussed, slow recovery.
On the call, or are you?
Excuse me?
I'm just doing through the Skype.
They don't have any presentation going, do they?
No, they do. There's a presentation.
I couldn't get in there.
So when you click on that link.
You know what? I'm going to mute them out, Mark. You just keep marching along.
Okay, sure. So as I say, traditional DR recoveries, it takes a long time to get the servers in the right place, the people in the right place, and also documentation is often very complex. If we go back to the scenario that I mentioned earlier, where my boss was telling me about the jumbo jet scenario, the other thing he showed me was his 1,000-page document of how step by step how to recover his AS400 system. And I've seen this in many different companies where the DR document is so detailed and has so many steps that somebody with no IT background potentially could follow it and recover the system. But typically, it is going to be a person who knows the systems and has a lot of expertise with those systems who's recovering it. And a documentation that's been prepared in that fashion is really just going to slow them down. What you typically see is stages get skipped because the person thinks, I'm not going to read through every line here. I know how to recover this portion of the server. I'm going to go ahead. So what I've seen typically work best, and if you plan your recovery plan to have streams, and we break out each stream as a checklist that can be handed to an engineer that understands the systems, and they're just making sure that they hit certain goals along the recovery plan. And we can have multiple streams happening at the same time, and we're not waiting for somebody else to finish things, or we're not tripping over each other. So if we rethink DR documentation, we can definitely be a lot more productive in our recovery. So what could it look like? So ideally, in an ideal scenario, obviously we'd have a very low RPO and an RTO, so we would recover quickly with minimal data loss. We also need to understand, we need to tier our applications. We understand what's the most critical and what are its dependencies, and we need to target those first. And if we can automate any of this process, then that's even better. So if we know that our SQL Server needs to be up before the app server comes up, for instance, if we can automate that, that's going to help us out to a large degree. We also need to be able to scale our recovery, as I mentioned earlier, to maybe it's just a few servers that are down, but they're very important. We need to get them up, or we need to be able to handle our large-scale disaster recovery, and also easy testing. So if it's expensive and difficult to test, we don't test very often. If we can test frequently, then we know the results and we can predict it. And in the event of a real disaster, we have a much better chance of success. So why Azure? So with the tools that we can talk about today to implement DR in Azure as a service, we can basically cover any Windows or Linux operating system that's running on any physical or virtual platform, all with the same solution. So that already takes out a lot of different complexities to it. We can also test DR plans quickly, cheaply, and easily. We can just failover into a secure area of Azure and have people test it anytime we want. And it's very cost effective because we're not maintaining hardware when we're not in a test or a DR scenario, and we're just paying a fee for storage and then per protected device, which is much lower than traditional costs. Additionally, we can use Microsoft's hybrid advantage, which means that whilst we are failed over into Azure, if we have existing Windows licenses and software licenses, we can run those systems at a significantly reduced cost. It's also, once we have this in place, we would be using the same tools that we would use for Azure workload migrations. So if you have older systems that they have a VMware farm that is running on old hardware, and at some point in the future we're going to have to replace that. Well, you can protect it right now using these tools, and it's the same process to fail over permanently as it would be in a DR scenario. So we can use this to kind of future-proof. We know where we're going to go with these systems once this hardware is expired. Azure also is industry leader in cloud products. They're in the Magic Quadrant for Gartner in all of these areas. Disaster recovery as a service, cloud storage. So they're well positioned from that point of view. And the tool that we're going to be talking about to perform disaster recovery as a service is Azure Site Recovery, which allows us to back up our systems to a DR solution with near continuous synchronization in most cases, providing you have the correct bandwidth available. The limitation there is Hyper-V, I think the closest to constant synchronization you can get is about 30 seconds. But with VMware or physical machines, you can get that almost instant. You can recover, so minimum RPO, and the RTO is very small as well. We're just bound by the time it takes to provision a new machine. And so here's how it works. So this green cloud on the left represents our data center. We have a physical server and we have 2 VMware farms. So the first thing that we need to do is we create a recovery vault in Azure, and then we deploy a site recovery server running the site recovery process and config server roles. We can install this on a standalone server, or what's most recommended is there's a OVX template that we can deploy straight into VMware, and that comes pre-configured. That will run on a Windows platform, Windows 2016. The template will come up as a eval license for Windows, so you have 180 days to activate it. Once that's online, we connect that to the recovery vault, and then we need to deploy mobility service agents to any machines that we want to cover with the solution. So we can do that manually. We can download and install those manually, or we can deploy them automatically from the process and config server, or we can use SCCM or whatever solution you would normally use to deploy software packages. So once that's in place, the process and config server will cache the data from the servers, compress it, encrypt it, and pass it into the recovery vault in Azure. And you can do this through ExpressRoute or your point-to-point VPN, but you don't need any of those. By default, it will just create a internet-facing endpoint within Azure that is replicating this data to in a secure data channel. So once this is fully replicated, as I mentioned before, you will have, assuming you have the correct bandwidth, it will run in near continuous synchronization. So you'll lose minimum data if you decide to fail over. And you can't, once you fail over, the machines are provisioned with that latest data into the Azure cloud, and will run there just in the same way that you would run any normal Azure VM. And then, assuming that we failed over a machine and we have recovered whatever broke on our VMware farm back on-prem, we can use the master target server, which is also a role that's installed on the template that I mentioned earlier. And we can use that to replicate back any Delta information whilst the server was live in Azure, and then we can fail back to our original server. Now, the only limitations here are if we fail over a physical server, we can't fail back with this mechanism to a physical server. So you would have to, in that scenario, fail back to VMware or Hyper-V. But that's essentially how it works. We can also do test failovers. So in that scenario, we can create test VLANs within Azure. We can specify that when we need to get a test failover, and we can give whoever we want access to those machines whilst they're running, and it won't interfere with the online production solution. And the production solution will still continue to synchronize any data that happens whilst we're running that test. And we can also instigate a production failover whilst we're testing. So it's pretty complete. We also have a thing called recovery plans. As I mentioned earlier, we all know that sometimes applications need to be brought up in tiers. We need to have certain components like a SQL Server needs to be up before we move to the next stage and launch our app server, our web server, or whatever. So with recovery plans, we can group these together, and we can group systems into protected systems into a recovery plan, and we can start them in groups, and we can have as many servers as we want within this plan and in various groups. And we can also attach additional steps, such as we can say, once you bring the SQL Server online, we need to run this script. And so we can build that into there as well. So once this recovery plan is initiated, there's a lot of automation there to bring up an entire solution. And as I mentioned earlier, we can do test failovers. It's built in. There's a test failover button within the solution. We can fail over a single system, multiple systems, a recovery plan. We've got a lot of control over what we do. There's no impact on replication from production. And because it's Azure, we can, with security groups or however we want to limit access to wherever they are, we can be pretty protected there. So let me just give you a quick run through of how this looks. In my lab here, I have this overview. For this demonstration, there's no systems outside of Azure, but I built this in the same way. This resource group represents a data center here. So we have a site recovery server with running all the roles. We have an app server, a database server, and a web server. And so they are all, this is my recovery vault here. We can also, with this solution, it's kind of a surface subject, but we can use pretty much the same mechanics to back up servers as well. So we can build our backup solution into the same method as our DR solution. It just uses it would use a different process to get the data there and store the data separately. So if we see here, I have 3 servers that are covered. They're all healthy in the real world. And let me just go back. So we can see those 3 systems. I've created a recovery plan. And so I can see within here that the items in my recovery plan, I've got a web server, SQL Server, and an app server. And if I click on Customize here, I have all my machines in separate groups. So we've got SQL, app, web. So all machines will be provisioned at the same time. And then one at a time they'll be booted. And then here we can add pre-action or post-action. That's where we could add those the scripts and things that I mentioned earlier. So what I did was I have this recovery plan here is basically exactly what I just showed you. I took this off earlier today, and all these machines are currently running. So if I go back to you can see data about how these were recovered. Just give me a quick sec here. I just got errors in this environment because it's turned off most of the time. So we can see here, I initiated this failover at 12:51, and all the machines here were provisioned at the same time. It all took 20 minutes. Typically, that would be a little faster than that. I think because this is a demo tenant, it takes a little longer. And then each one of the systems was booted a few minutes apart. So as soon as the SQL Server was It took 2 minutes to boot. As soon as that was done, 114, the next server came up. 116, the next server came up. And so all of those systems were recovered into my Cloud OU here. So they're all using, I configured them during the test failover. I pointed them to my my test failover network, which has network security groups on, so it's isolated. And I brought all these systems up in here, and they're ready to access. So that's the actual interface. And then let me. Okay, so how can Bennett AO some help? So we offer Azure DRS service assessments, where we can look at your environment. We can tell you if you're assess the readiness of your Azure tenant if you have one yet, or help you configure one if you don't. We can do a cost assessment. We have tools where we can run through and understand the dependencies you have, how your machines fit together, and how cost effective or how much it would cost to have a solution in place where we cover these with the DR plan, and how much it would cost if we failed them over permanently. And we can also help you plan this whole thing. Moving forward, we can use that data to work through a proof of concept engagement or a full engagement. We also offer ongoing services. The thing with Azure is it changes frequently, and we can come back in and make sure that your tenant is optimized and as cost effective as it can be, because sometimes there's new technologies that come out that could be saving us even more money, and we need to know when to adopt them. And so we can come back in and make sure you're using the right kind of storage, you're using the right tools and all that kind of thing. We can also talk about long-term cloud adoption, and which we can look at your systems with our Azure workload migration assessment, and we can identify what's a really good candidate for permanent location in the cloud, and how that would look and how much that would cost, and just general road mapping into the future as well to help you to get to where you need to be. So that's a little quicker than I thought I would, but that's all the slides I've got. Do we have any questions?
So, Mark, we had a question in the thread, and it looked like John and Jason were answering it, but the question was Azure for Windows and Linux only, so nothing for Unix or IBM, iSeries, Z-Series, etc. And again, I think we kind of answered those, but just curious to hear your thoughts.
Yeah, those are what's listed currently as being supported by Azure Site Recovery, but it is changing all the time. I mean, anything that you could host in Azure, I would imagine, would be supported by this at some point. So, yeah, currently Windows and Linux. Are there any other questions that came up? Or? Nope. Okay.
Perfect. Well, thank you, everybody, for joining. We are going to try and do one of these webinars once every month. If you have any ideas for topics that you'd like to hear about, our experience spans the Microsoft realm, from infrastructure to development through collaboration, pretty much anything that says Microsoft on it. So feel free, if any follow-up questions come up, or if you do have any ideas for any topics, email myself, email Brian Connolly, or email the BA Events email. However you got the invitation to this event, go ahead and email that address back, and we will be happy to answer any questions or take your suggestions for future webinars. And of course, as always, let us know if there's anything else we can do to help. We will be sending this recording of this webinar out to everybody, so look for that in your email and feel free to distribute it. But thanks again for your attendance, and hope everybody has a great rest of the day and great weekend coming up.
Yeah, thank you, everybody. Appreciate it.